we go to video, video number 8. Video number 8. Under this video number 8, we are going to techniques of partial fraction. Techniques of partial fractions. Oh, sorry, I repeat. I mean techniques of integration. We have different methods of integrating a given algebraic functions. We are going to consider three main techniques of integration. The three main techniques of integration that we are going to consider here are: 1. Integration by partial fractions. 2. Integration. Just a minute. Let me set the video. Yes, I repeat. We go to video number 8, and under this video number 8, we're going to consider techniques of integration. Techniques of integration. There are three main techniques of integration. Namely: 1. Integration by partial fractions. 2. Integration by algebraic substitution. And 3. Integration by part. We will consider only the first two types of integration. The first two types, that is integration by partial fraction and integration by algebraic substitution. 1. Integration by partial fractions. In a rational expression, that is, if a rational expression is not in a standard integral form, it can be made, that is, it can be transformed into a standard form by splitting it into partial fractions. Example number 1. Evaluate the integral of 4x minus 5 everything over x plus 1 into x minus 2 dx. Solution. First, split the rational expression of rational function 4x minus 5 over x plus 1 into x minus 2. So now what am I saying here? The question is, we should evaluate the integral of 4x minus 5 over x plus 1 into x minus 2 dx. As we can see, the expression we are to integrate is a rational function, that is an algebraic rational function. The first step we do is to resolve this rational function into partial fraction first before we can integrate. So the solution: first, split the rational expression or rational function 4x minus 5 over x plus 1 into x minus 2 into its partial fractions. So then we follow the normal method of resolving algebraic function into partial fractions. So we say let 4x minus 5 over x plus 1 into x minus 2 be equivalent to a over x plus 1 plus b over x minus 2, as we did during the topic of partial fraction. Now, the next thing is to clear the fractions by multiplying through by the LCM, i.e. the denominator of the left-hand side. This will yield 4x minus 5. 4x minus 5 is equivalent to a into x minus 2 plus b into x plus 1. Call this identity number 1. Choose value of x that will eliminate one of the contacts a and b at a time and solve for the other constants. E.g., at x equals minus 1, equation 1 becomes 4 into minus 1. That is from equation 1. We have 4 into minus 1 minus 5 is equals to a into minus 1 minus 2 brackets plus b into minus 1 plus 1. You know that minus 1 plus 1 is 0, and 0 times b is 0. So we are left with, now 4 times minus 1 is minus 4. Minus 4 minus 5 is equals to, minus 1 minus 2 is minus 3. So minus 3 times a is minus 3a plus b times 0, because minus 1 plus 1 is 0. So that is b into 0. b into 0 is 0. b times 0 is 0, as we know. Minus 4 minus 5 is equals to minus 9, which is equals to minus 3a. Or a equals minus 9 over minus 3, which is equals to 3. So the value of a is equals to 3. Now, choose another value of x that will eliminate a, that will eliminate constant a, so that we can solve for constant b. And what value of x are we going to choose that will be able to eliminate constant a in equation 1? And that is equals to 2, so that 2 minus 2 will be 0. So at x equals to equation 1, I beg your pardon, this is equation 1 here, not equation 2. Equation 1 becomes 4 into 2 minus 5 is equals to a into 2 minus 2 plus b into 2 plus 1. So I have 8 minus 5 is equals to a into 0, because 2 minus 2 is 0. 0 times a is 0. So 8 minus 5 is equals to a into 0 plus 3b, because 2 plus 1 is 3. So 3 times b is 3b. Therefore, 3 is equal to 3b, or b equals 3 over 3, which is 1. So the value of a is 3, the value of b is 1. Now, we can now write out our partial fraction. So the partial fraction, 4x minus 5 over x plus 1 into x minus 2 is equivalent to 3 over x plus 1 plus 1 over x minus 2. So I am now ready to answer the question. That is to find the integral of 4x minus 5 over x plus 1 into x minus 2 dx. So this will now, since 4x minus 5 over x plus 1 into x minus 2 is equals to 3 over x plus 1 plus 1 over x minus 2. So the integral of 4x minus 5 over x plus 1 into x minus 2 dx is the same thing as the integral of 3 over x plus 1 dx plus the integral of 1 over x minus 2 dx. Now, the integral of 3 over x plus 1 dx is 3 ln x plus 1. The integral of 1 over x minus 2 dx is ln x minus 2 plus c. So this is my answer. This is my answer. This is my answer. Now take note. Either we leave it this way or we write 3 log x plus 1. Ln x plus 1 is the same thing as log x plus 1 to base e. Then plus, instead of ln x minus 2, I can write log x minus 2 to base e plus c. Or I just write 3 log x plus 1 plus log x minus 2 plus c, which is the same. This is now apply the law of or I can leave it this way. I can leave it this way. I can leave it this way, or I can continue. I can continue by saying. I can continue by saying that this is the same thing as log x plus 1 all square, then everything over this, so that will come into that. So, like that. Now, let me repeat this. I can say this is the same thing as log x plus 1 cube. Applying the law of log, plus log x minus 2 plus c. This is the same thing as this. The same. Now addition is multiplication. Addition is multiplication. So this is the same thing as the log of x minus 2 into x plus 1 all cube plus c. I can leave it this way. So I can leave it this way, or I leave it this way. That is my final answer. My final answer.